So we're running a race. And if we say, like, this was the start line and the finish line, stick with me for this analogy. Actually, I should probably build up here for anybody playing with us at home. I'm good. 19. So let's say this is the start finish, or no, maybe this is the start finish, right? And we ran around here, and this was probably like a little fall break or whatever, and we ran around here, and we went into the 8th grade textbook for a minute, and we're coming around the bend, and we've got some content still yet to cover. And I know that we can more efficiently get to the finish line if we just fail and just run across the center of the track. And yes, so that is what we're about to do, like in the analogy sense. So today's lesson is meant to have this big old lab that goes along with it, and it's meant to take 2 days. We're not doing that. 1, because you're accelerated 7, and you don't need that much time to absorb the information. And 2, it's a waste of time. We have more content than we need to learn before we get to the end of the year.
But if you go all the way around, you get
Correct, but that's not the only focus. Like, we don't have time for more exercise. Like, we just need to get there. As sad as it is, and it does not make me happy, but that's where we're at. 19 all day long. So I'll give you the rest of that time, especially because the homework's really big. I'll give you that or do we just want to dive in?
No,
I'll give you that time somewhere. You know, in front and back end.
yeah, I'm doing my
Yeah, you actually don't.
Look, how about I make up this promise? Who's back here giving me sass?
That was Rachel.
I will finish this lesson early. But I never promise. I pinky promise. I pinky someone.
The one time you promised, actually it was like half the time.
Okay, so imagine. Now again, we're going to go really, really fast. So imagine a can of tennis balls. And you wrap a string around that can. Now, what I want you to consider is if you took that string off the can and turned it vertically, do you think the string would be shorter than the can, as long as the can, or as tall as the can, I guess, or longer? Talk with your partner, make a hypothesis. We did something different. No, chapter 8. And then we had 834 after that. Just string, yarn, whatever. Yo, doesn't mean that as tall as 3 tennis. I mean, have you seen a tennis ball can? No. It's 3 tennis balls
You
tall.
didn't tell us it was a tennis ball here.
It's right here. Yes, I did.
You didn't lie. You didn't. All I heard was there's a pan.
Mr. Hudson, it sounds like this guy's absolutely waste of time. And I don't know why he's doing this.
Anyone have a prediction rooted in some kind of information?
No.
Mine?
I think it'll be
Do you think it'll be the same length as the can, like as tall as the can? So we're taking our string around the front, around the back, and then we're going to turn it and compare it. Right? So Nye is predicting it's as tall as.
So what I'm going off of is that you're basically saying then one tennis ball, if you took it out, is going to be as tall as I can, and it's not going to.
No, that's not what she's saying.
No, like,
She's saying if you took a tennis ball and cut it straight across the middle, right, the string wrapped around it, that laid out length. Okay, so Will says shorter.
I agree with Naya.
Amy says never mind.
I think
All right, we're going to move on.
I think it's going to be around it.
I'm not going to tell you if you're right or not. You'll know by the end of class.
Is this going to be colored in the bottom of the paper? I honestly forget it.
If we had the time, what I would have you guys do, and I am sorry that we're skipping the lab and doing I want to do more of that fun stuff, and hopefully after the test, and that hurts me to say it too, but after the test, hopefully we'll do some more fun things in labs and stuff outside when possible. We were going to blow bubbles and look at them popping on the, yeah. So,
Why didn't we do that?
because it's a waste of time, and we have more you're an accelerated setting. Yeah, you're in accelerated setting. Why you chose this class is to move faster. Sorry, if you want to do every little activity, bump back down into the regular track, which is still an option. So, if we had the time, you would go around the school measuring circles. And what I would have you measuring is the distance around the circle, which is why this is so hard, is measuring circular is very difficult. And then you compare that with the distance across. And what you would see is that every time you set that up, your circumference, the distance around, compared to the diameter, the distance across, would reduce down to approximately, I guess I should make the approximate equals then. So go ahead and write that down. Every single circle, now if it's a perfect circle, right? I can't measure my leg and be like, oh, it doesn't work. It's not a perfect circle. Even the Earth, not a perfect circle. Even our orbit, not a perfect circle.
It's an oval.
Yeah, it's approximate equal. And that is pi. Now, I saw on a game show, it wasn't a super high value, but in tens of thousands. So, worth tens of thousands of dollars. The question was, what is the common name for the ratio of a circle's circumference to its diameter? It was a really complicated asked question. It's pi. That all the dude needed to know. It's pi. Pi, circle. What do you think of when you think circle? Pi. You should always think of pi.
Did you get it right?
Oh, by the way, we're going to do our pi memorization contest because I got sick last week and everything. We're going to do that on Friday as part of the canteen. I need to talk with Miss Pettigrew and stuff, but since I'm running the dance, I'm in charge in there. So right when we switch over to canteen part of the day, because we're having canteen on Friday, anybody who wants to do the pie memorization contest, that's going to happen in the family room right then, right before. You don't have to. Just for whoever wants to. I forget, but because I freaked out. I'm like, that's in my class. I teach that. And it would not have been Are You Smarter Than 5th grade, because this is above 5th grade content. But I like those game shows.
Are you smarter than 5th grade?
So, could you just divide 7 by 21? Do the whole equation, keep going as far as
7 by, you mean divide 22 by 7?
Yeah, sorry.
So if you do the long division of 22 divided by 7, or you don't even have to do the long division, you can do it in your calculator. So I have pi up there, right? Here's what your calculator gives you for 22 over 7. 3.1428571. So it's accurate out to the hundredths place because we all know that pi is approximately 3.14. Right? Go ahead and write that down just for good measure. Now, what that really is telling us, and why we care so much about it, is if we are able to determine the distance across something, or how big your tire is, how big your wheel is, how whatever, then one rotation, one distance around the whole thing will be this number times your distance across. So that turns into our formula, circumference equals pi times diameter. Now, what I want you to write down, which will help you remember this, and I forget if we've talked about this yet or not. Crust is pi dough. right? The crust is the pie dough. Crust is pie dough. It's the formula.
Yeah, because it's like when you have variables, like you don't say 2 times x, it's 2x. That's why.
So it is pi times diameter. You can say it like that. Now, also, we have that circumference is pi times 2 times the radius, because 2 times the radius is your diameter. They're interchangeable. That is just called replacement. Substitute. That's an arrow, but a very small arrow. It is a Greek letter. So actually, pi was a letter before it was ever 3.141594265. It was in the alphabet. This is why I keep this here. There's a lot more of these awkward Greek symbols. And a few of the other ones get used for other mathematical values. But, like, when we know that there are 12 inches in a foot, or 5,280 feet in a mile, that's just like pi. There are 3.14 times the diameter in a circle. So let's go back to the question about the tennis ball can. What do we know about our tennis ball can? It's 3 tennis balls tall, which means it would be 3. Well, how tall is the tennis ball? Right? That's the. If we think about the tennis ball as a circle, what's the distance straight across the middle? What's that called? Diameter, right? So it's 3 diameters tall, right? Because each of the tennis balls is a diameter tall. Because we know, and you can draw this if you need to, straight across the middle is a diameter. So please draw yourself a little picture if you need. So it's 3D tall. And if we had that string wrapped around the circumference, we said circumference is 3.14 D. So the string would be taller than the can.
That's why I asked, did anyone say it was taller? Because no one even mentioned.
I tried to paper. I kind of went out.
Hey, did you say it was taller?
No, because I didn't raise my hand. You said, okay, moving on. Anyone mention
Well, I just didn't want to get an answer.
Wait, you didn't call me.
I should have raised my hand. Technically, I was right.
All right, so the general relationship here can be manipulated a few different ways. Crust is pi dough, right? But if you are given the circumference and looking for diameter, if we isolate diameter here, how would we isolate diameter? Divide by pi, right? So diameter is circumference divided by pi. You might want to throw that formula in your notes because sometimes you will be asked for the diameter when given circumference. Now, also, something worth writing, but most of us are like, well, duh. What is diameter? Give me another formula for diameter. 2 times the radius, right? Which then also radius is half the diameter. I love when people come to me, they tell me, Mr. Hudson, this problem's asking me for radius, and that's impossible because the only formula that I have gets me diameter. Bro, right? Like, bro. Right? So diameter and radius are like those siblings that look like twins, but they're not, right? Like we're actually different, but we're really easy to figure out, like one versus the other. So if you have radius, you can get diameter super easy. Same thing, diameter, you can get radius super easy. Does that make sense with us? No. Good. Moving on.
No.
What? But I have to set that down so I can actually touch things. All right. Now, if you actually want to number things that we're going to actually answer, problem 8. No, sorry. Well, that was the revisit the can and then talk about it.
I did not like
If the equator is 7,926 miles.
Whoa.
Awesome.
Then, sorry, not the equator, the diameter. I was about to say, that seems small. The diameter, you cut straight through the Earth, and don't ask me whether it's the short way or the long way, because the Earth is an oblong spheroid. It's a fun word to say. It's an oblong spheroid. So here's the hypothesis on why the Earth is what it is. So take a ball, right?
Why is there a fake cardboard?
Take a ball, and imagine that it's got a little squish to it, like the water on our Earth, and spin it outward. Or like spin it on something. What would happen to the values in the middle? Or it pushes outward, right? Centrifugal force tells you that when you spin something, it's going to rotate with an outward force. So all the water pushes towards the edges. Also, if you want to look up what if the Earth was flat, there's a really interesting video about how gravity would work and everything else. But so oblong spheroid, right? Figure out the circumference. If that's your diameter of Earth, figure out your circumference. Now, on your calculator, there's a pi button. Unless you've been told to use 3.14 for pi, I always suggest using the pi button. But listen carefully. If the test tells you, you're not listening. If the test tells you to use 3.14 and you use the pi button, you will get it wrong. So if on the air test, or whatever the heck they're calling it now, they tell you use 3.14 for pi, use 3.14. Don't be arrogant and be like, well, I'm more precise. I'm going to use the pi. I always say if you've got the pi button, use the pi button. But on the test, make sure you read their directions when it comes down to circles. I had kids, like, that's feedback that I've gotten in years past, is like, you got to read carefully and check what they're asking you to use. We are looking for circumference. We've been given the diameter. I always like to write my formula out first because it helps me to remember it. So we're now going to plug in.
It just gives you 7,926.
Oh, then your calculator's in the wrong setting. Then you need to go and put it into scientific. So if you hit, remember, 7,926.5. So then mode, go down one. No.
It needs to be in dead, drag, or grab.
It needs to be in degrees. Oh, sorry, it's not the. Hold on, I believe you need to put it into classic as opposed to math print. Yep. So hit mode. So you should normally. Everyone grab a calculator if you don't have one. Everyone grab a calculator. Everyone grab a calculator if you don't have one. Or look on one. At least look on a part. Hit mode. I need your ears for a minute. You're going to make me break my promise. I don't want to. Hit mode. In that menu, you will see it has normal, scientific, like norm, sci, and then like GRD. Don't ever, E and G, that's English. You should be in normal or scientific. Either way, scientific is going to give you values using scientific notation, which we're going to cover when we come back from break. Normal, scientific are almost the same thing. Down two more option settings from there. It has classic versus math print. Math print puts things in the most simplified mathematical way, which saying 7,926 pi is nice and it's precise and it's great. But if you select classic, it will give you your answer as a decimal, which is the answer of what?
2.4. What? 2.4.
What?
No, it's not 2.4.
That's a weird.
Unless you so if hold up, some of you are getting 2.4. If your calculator is in scientific. You got that as your answer, which is actually this. Now, really brief review of science, well, not review, really brief preview of scientific notation. Give me your eyes. Every single eyeball in the room, up here. Every single eyeball in the room, up here. This, after this, you're like, oh, got it. This exponent, when you see the times 10 situation, 1, this is scientific notation. Welcome to scientific notation. 2, has to be a times 10. There's no other base value that we use. 3, this tells you how to move your decimal. So, if it says 4, you grab it and move it 4 to the right. If it said -4, you would grab it and move it 4 to the left. That's scientific notation.
Doesn't the number you multiply the 10 exponent by have to be greater than 1?
Nope. So it can be negative, it just moves it left. So when you raised your hand, it was like you just stopped listening. It literally just said if it was -4, while your hand was up.
No, not the exponent, the number.
What, this? Oh no, it needs to be between 1 and 10.
Okay, yeah.
So it has to have a single digit in front of the decimal. It could be negative, could be positive, doesn't matter that, but it needs to have a single number there. Now, I could write this as 24.9 times 10 to the third. That's the same thing, but it's not scientific notation. All right, now we're talking about circles, not scientific notation, really. Yeah. What? What? Yeah. Yeah.
So does that mean if it is in multiple digits, you could just move it around?
Yeah. But we're doing that after break. Don't worry about that. I don't know if we want to do additional challenges. Ha! We're done. Okay. So, all you pouty pollers, you're like, I want to blow bubbles. You have 20 minutes to work on your homework. Yeah.
More time than that.
Right? Are we in here till like 35? Ah, pink promise. I would encourage you guys to work on these problems together, but hey, but the thing is, some of you don't work well with each other. So, all because you're like, great, we have time, we should work together. That doesn't mean you're going to be more efficient necessarily. Make sure you work with somebody who keeps you efficient. You should be able to bust these problems out very quickly. So, if diameter is 1 centimeter, circumference is pi times diameter. Oh, okay, so it's pi, right? Like, you can get through these really fast. Here, circumference will be 7.2 times pi. And then figure it out as a decimal, right? Last thing I'm going to say. Unless the question specifically asks you to keep it in terms of pi, you must give your answer as a decimal. If it says terms, guys, like one last thing. I'm going to give you 20 minutes. If it says leave it in terms of pi, that means don't do the multiplication. It means leave it with pi as pi. Unless it says that, do the multiplication, write it as a decimal. When you're writing as a decimal, at least go to the hundredths place. At least go 2 decimal places. Yes. That would be if it says in terms of pi. Yeah, but so like A, since it doesn't say leave it in terms of pi, your answer is actually going to be 3.14. Yeah, because that is 1 pi, right? That is the value of 1 pi. But label, right? So this will be centimeters. This one will be meters, and it'll be like 20-something. So make sure you get labels on these values. I'm having that issue with my high school math too. I'm not even progressing for not labeling. Because units and units squared are not the same thing.
What are you doing?